Alright, this is another IB question, and today we're going to be looking at integration using substitution. So this is going to be kind of a crazy little question here. So what we're going to do first is we're going to use this substitution, u equals 1 over x, and we're going to show that these two integrals are equal to each other. So what we're going to do is we're going to start with this first one. We're going to go integral from 1 to alpha of 1 over 1 plus x squared dx is equal to the, we're going to get it equal to that later. So we're just going to start with this, and we're going to use the substitution. So it tells us we're going to substitute, and this is very nice of them, isn't it? Isn't it very nice? Everybody says, IB's out to get me. IB is not out to get you. IB's trying to help you, man. So here we go. We got u equals 1 over x, but I'm going to do a substitution for x, so I really need to know what x is. So what I'm going to do is I'm going to multiply by x, I'm going to divide by u. And so when I do that, I'm going to end up getting x equals 1 over u. And so now I can do the derivative so that I can dx, because I'm going to need the dx as well. So dx, take the derivative, and that was u to the negative 1. You put the negative 1 in front, right? So that's u to the negative 1. And so you put the negative 1 in front, and then you decrease it by 1, so u to the negative 2, so 1 over u squared du. Okay, because we don't know what u is, we got to take the derivative of that as well, so 1 over u squared du. Alright, so now we're actually going to go ahead and make those substitutions and see what we can do. So we substitute, we go integral from 1 to a of 1 over 1 plus x squared. Now x was 1 over u, so we're just going to change this to 1 over u squared. And then dx, of course, was negative 1 over u squared du. Now, we got one problem here. I hope you recognize, and he was like, oh man, he's making a silly mistake. No, I'm not making a silly mistake. I just wanted to point this out. We changed it from x to u. Now what that means is that this used to be integrate from x equals 1 to x equals alpha, and that's what we were integrating before. But we don't want to integrate from x equals 1 to alpha because we don't have an x anymore. We got u. Now in some situations we just leave it because we know we're going to put the x back in. But in this situation right here, I don't have no x's. I'm not going to be putting x back in. And because I'm not putting x back in, I actually need to change this, so this is u. So how do I get u? Well, u equals 1 over x. And so what we're going to do is we're going to change this. Instead of x equals alpha, it's going to be u equals 1 over alpha. So this is 1 over alpha. And this is going to still be 1 because u equals 1 over 1. And so that's going to stay as 1. Alright, so I got a little bit of a change there. Now we're going to go through and we're just going to simplify this just a little bit. And so the negative, of course, I'm just going to throw the negative out front because I don't know what else to do with it for now. So I got 1 over alpha. And then I've got 1 over u squared. So the one on top is going to stay the same. And then I got a u squared, which is going to be on the bottom. So that u squared is going to be multiplied by the 1, which will be u squared. And then I got 1 over u squared, which is going to be multiplied by u squared, which is just going to be 1. Well, that's mighty convenient. Look at that. U squared plus 1 and 1 plus u squared. Holy smokes, man. I told you, they tried to be nice to you, man. So then we got du. And so the final thing is to recognize that the integral from 1 to 1 over alpha is equal to the negative of 1 over alpha to 1. And so that's where the negative goes, and that's why the little thingy, I don't know what those are called. I should probably go look that up. That's why those changed positions, the restraints, I guess. And so those are going to change, giving us the integral from 1 to 1 over alpha. It's now positive because I changed the direction of 1 over u squared plus 1 du. The next thing I got to do is part B. Because in part B it says, hence show that arctan of alpha plus arctan of 1 over alpha equals pi over 2. So what we're going to do is, well, since it says hence, I'm probably going to use this. So let's start off with that. So integral from 1 to alpha of 1 over 1 plus x squared dx equals the integral of 1 over alpha to 1 over 1 plus u squared. Yeah, I can't sing and think at the same time. Sorry, that's just something I can't do. Anyway, so here we go. We got it. We're going to actually do the integral. Now, hopefully you recognize this integral, right? Hopefully you recognize this integral as being the arctangent, right? We know that the integral of 1 over a squared plus x squared dx is equal to 1 over a arctan of x over a plus c. And I'm telling you, they are trying to be nice to you here. They even made a 1. I don't know what else they can do. So anyway, we got 1 over 1 over x squared. So this is going to be 1 over a, which is just 1. So this one is arctangent of x evaluated from 1 to alpha. And this one is going to be the arctangent of u evaluated from 1 over alpha to 1. And this is why it was important that we change these so that it's in terms of u now, because now I can just put it straight in for the u. Otherwise I have to put x back in for the u, and yeah, it's not going to work. So we go ahead and work this out. We go arctangent of alpha minus arctangent of 1 equals arctangent of 1 minus arctangent of 1 over alpha. Now, who knows what arctangent of 1 is? Ooh, I do, Mr. Bower. I know what arctangent of 1 is. Arctangent of 1 is pi over 4. And you should be able to figure that out. If you don't know the answer, if you don't know that, then what you need to do is you need to go over here and you need to draw your little triangle. And you say, okay, well, if arctangent 1 is my ratio, so the opposite over adjacent has to have a ratio of 1. So that means these two sides have to be the same. In order for those two sides have to be the same, we know exactly what that angle has to be. That angle has to be 45 degrees. Now, if that part was confusing to you, you probably shouldn't be worrying about integrals with trig functions right now. What you should be worrying about is how to do trig. You need to go look up the unit circle and kind of play with that a little bit. And once you're fully enjoyed with that, then you can come back to this question and we can finish it off. So what we're going to do is we're just going to go, okay, that means arctangent of alpha minus pi over 4, because that's our 45 degrees right there, equals arctangent of 1. So again, pi over 4 minus arctan of 1 over alpha. And then, of course, we're just going to add the arctan of 1 over alpha here. We're going to add the pi over 4 there. So we end up with arctan of alpha plus arctan of 1 over alpha equals pi over 2. Why you would ever want to know that, I don't know, other than the fact that it does answer this question. All right, so we's done with this one.